Sample 7, the famous Allende meteorite lit up the skies of Mexico that fell to Earth in February 8, 1969. Scientists melted and chemically analyzed the small pieces of meteorite and found the traces of both radioactive potassium-40 and argon-40. Laboratory studies have shown that potassium-40 decays into argon-40 with a half-life of 1.25 billion years, and that all the argon-40 of the meteorite must be a result of such decay. By comparing the amounts of two substances of meteorite samples, science determined that only 8.5% of potassium-40 present in the rock remains today. The rest has decayed to argon-40. How old is the rock that makes up the Allende meteorite? Pronounce that wrong. So we can model the radioactive decay with an exponential function, which Q is the current amount, and then Q naught's the original amount, because we're given the half-life. So let's use this function. It's the same one we just used in the last one. So 1/2, and then T divided by T of half. Okay? So from radiometric dating, we compare the current amount to the original amount. So the equation, so what you're going to do is you're basically dividing the current amount divided by the previous or the original. And this ratio here, I believe it says only 8.5%. So you're going to make this into 8.5. You can make that into 8.5%. So this is going to be 0.085. That ratio is going to equal to 1/2 T divided by the T of the half-life. Okay. Now the question is, how old is the rock? So we're solving for T. So we got to solve for T. So T we don't know, but what we do need to know is we need to figure out the half-life. Now there is a half-life formula. Okay, so here's the mess though. We've got the T of half too. I need to plug that in. T of half, and I guess we need to plug in the actual amount here. We got to plug in the 1.25 times 10 to the 9. So the T of the half, let's plug that in right now. The problem here is that I'm solving for a variable that's in the top as an exponent. And so how do we bring this? We got to bring this exponent down. What do we do to both sides? We take the log of both sides. So I'm going to do the log of the left. And when I do the log of the right, it brings down the exponent in front times log of the base, log of 1/2. Okay. All right. So next thing I can do is I can divide both sides by log of 1/2. This is not a great thing to have to pull out here. And we've just done a crash course. We haven't even taught logs. Okay. So when I haven't even taught logs to you directly, you've seen it in other classes, but not in this one. So 3.556. So 3.556 equals T divided by 1.25 times 10 to the 9th. Okay, so what I need to do now, I need to divide both sides by this 1.25 times 10 to the 9th. So 1.25 times 10 to the 9th. And so T will be, I'm going to use the original answer here because that might make a difference. I'll look at it real quick. So it'd be 4.45 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4.45 times 10 to the 9th. Yeah, let's just keep it like that. Years. So that's going to take 4.45 billion years old. So it's 4.45 billion years old. Very old.